Hey physics friends, Mr. Collier here. I have another sample problem with kinetic energy for you. Today we're looking at a 2 kilogram ball that is going 6 meters per second, bounces off the ground and is only going 2 meters per second. So the first thing it asked you was how much kinetic energy does it have before the bounce? So before it bounces, its mass is 2 kilograms and its velocity is 6 meters per second. And kinetic energy, if you'll recall, is 1/2 mass times velocity squared. This becomes as simple as plugging in our numbers. So that is 1/2 times 2 kilograms times 6 meters per second. And we're going to square just the 6. Now you'll notice this is not a coincidence. Physics teachers love when they're doing kinetic energy to make the mass 2 kilograms and play around with the velocity, because what you'll notice is that 2 times 1/2 is 1, and so it really just means you're looking at the velocity squared. It's a little trick that we do just to make our lives a little easier and your lives a little easier when you're calculating. So anyway, 1/2 times 2 is 1, so we're really just multiplying 6 times 6, which would be 36 joules, and that is our before the bounce. And then after the bounce, we have a reduction in speed. The ball is going slower because the bounce has absorbed some of that energy, which we'll talk about more as this chapter goes on. The mass of the ball won't change by a bounce, but its speed does. Its velocity goes down to 2 meters per second. And we'll notice that what this does to the KE is reduce it substantially. We've still got the 1/2 times the mass, and now we're taking our new speed, 2 meters per second, and we're squaring that. So 1/2 times 2 is still 1, and we've got 2 squared is 4, so it's 4 joules, right? And this is actually 9 times more before the bounce, or 9 times less after the bounce, right? We divided it by 9, and so that is a substantial change. This goes back to something I mentioned in yesterday's video, which is that when you change the velocity only, right, in this case we kept the mass the same, when you change the velocity only, it actually ends up being the square of what you did to it. So in this case, we divided the velocity by 3, and then you square that is 9, so it actually reduces it by a factor of 9, not by a factor of 3. Again, it's that idea that the speed has more of an impact on the kinetic energy than the mass does. Another thing we can say, besides how many times less is the energy, is we could simply say how much energy is lost, and that would just be 36 joules minus 4 joules, right? 32 joules of energy were lost. And when we say lost, that's not the same as destroyed. I didn't actually ask this in the question, by the way. I'm just pointing out that that's another thing I could ask you when we're talking about kinetic energy. All right, that's it. Let me know if you have any questions.